Welcome back, OS enthusiasts, to another exciting episode of Operating Systems Crashcast. I'm your host, Victor, and with me as always is the brilliant Sheila. We're continuing our journey through Season 1, Chapter 1, Introduction to Operating Systems. Today we're diving into Section 1.5, Operating System Operations. Sheila, are you ready to explore the inner workings of OS operations?
Absolutely, Victor. I'm excited to unpack this crucial aspect of operating systems. Before we begin, listeners, if you haven't caught our previous episodes covering sections 1.1 through 1.4, I highly recommend giving those a listen for some helpful context. Now let's get started.
Great point, Sheila. And speaking of getting started, it's time for our quiz question. Listeners, here's something to ponder. What's the primary purpose of dual-mode operation in modern operating systems? Keep that in mind as we explore today's topic. Now, Sheila, let's lay down some fundamentals. What are the key concepts we'll be covering in this section?
Excellent question, Victor. We'll be diving into several crucial concepts that form the backbone of operating system operations. These include multiprogramming and multitasking, dual-mode operation, which ties into our quiz question, timer interrupts, system calls, and I/O handling. These elements work together to ensure efficient and secure operation of our computers.
That's quite a list. Let's start with multiprogramming and multitasking. Can you explain these concepts in simple terms?
Of course. Think of multiprogramming like a chef preparing multiple dishes simultaneously. The chef, our CPU, switches between different tasks, programs, to make the most efficient use of time and resources. Multitasking takes this a step further, giving users the illusion that multiple programs are running at the same time, much like how a juggler keeps multiple balls in the air.
That's a great analogy, Sheila. Now let's move on to dual-mode operation. This is a critical security feature in modern operating systems, right?
Absolutely, Victor. Dual-mode operation is like having two levels of access in a secure building. We have user mode, where most programs run with limited privileges, and kernel mode, where the operating system has full access to hardware and can perform privileged operations. It's a bit like having a regular employee badge versus a master key that can access all areas.
That makes a lot of sense. So how does the system switch between these modes?
Great question. This is where system calls come into play. When a user program needs to perform a privileged operation, like accessing hardware or creating a new process, it makes a system call. This is essentially a request to the operating system to perform the operation on its behalf. The system then switches to kernel mode, performs the requested operation, and switches back to user mode.
Fascinating. It's like the program is asking permission from a higher authority to perform certain actions. Now, you mentioned timer interrupts earlier. How do these fit into the picture?
Timer interrupts are crucial for maintaining control of the CPU. Imagine them as an alarm clock for the operating system. At regular intervals, the timer generates an interrupt, forcing a switch to kernel mode. This prevents any single program from hogging the CPU indefinitely and allows the OS to make scheduling decisions.
That's a clever mechanism. It ensures fair use of resources and prevents potential system lockups. Now, let's talk about I/O handling. How does the operating system manage input and output operations?
I/O handling is a complex but essential part of OS operations. When a program needs to perform I/O, it typically makes a system call. The OS then takes over, managing the interaction with the hardware. This could involve reading from or writing to a disk, sending data over a network, or interacting with other peripherals. By centralizing I/O operations, the OS can optimize performance and ensure security.
It's amazing how all these components work together to create a seamless user experience. Before we wrap up, could you touch on how these concepts contribute to the overall efficiency and security of modern operating systems?
Certainly. These mechanisms work in concert to achieve several goals. Multiprogramming and multitasking improve CPU utilization and responsiveness. Dual-mode operation and system calls provide a secure environment by restricting direct access to hardware. Timer interrupts ensure fair CPU allocation and system responsiveness, and centralized I/O handling improves efficiency and maintains security. Together, they create a robust, efficient, and secure operating environment.
Thank you, Sheila, for that comprehensive explanation. Now, let's quickly recap the key points we've covered today. 1. Multiprogramming and multitasking improve resource utilization. 2. Dual-mode operation provides a security barrier between user programs and system resources. 3. System calls allow user programs to request privileged operations safely. 4. Timer interrupts ensure fair CPU allocation and system control. 5. Centralized I/O handling improves efficiency and security. And now, it's time to answer our quiz question. Sheila, can you remind our listeners of the question and provide the answer?
Of course, Victor. We asked, what's the primary purpose of dual-mode operation in modern operating systems? The answer is to provide a security barrier between user programs and system resources. By separating user mode and kernel mode, the operating system can prevent unauthorized access to critical system components, ensuring system stability and security.
Excellent explanation, Sheila. And that brings us to the end of today's episode. We hope you've enjoyed this deep dive into operating system operations. If you found this informative, please subscribe to Operating Systems Crashcast and join us next time as we continue our journey through the fascinating world of operating systems. Until then, keep your systems running smoothly.